All right, this next video is on Charles' law. So like the other one, we've got an equation where we're changing volume and temperature for this one, but now it is a fraction. So I did two examples because it's different algebra when you're solving for the top versus the bottom. Now with Boyle's law, it didn't matter which units you used as long as they were the same on both sides. For Charles and our last one, Gay-Lussac, your temperature has to be in Kelvin. So to get Kelvin temperatures, that's going to be degrees Celsius plus 273. The Kelvin scale is based on absolute zero, and it has to do with how fast the particles are moving. We need to use that for the math to work out. So with these problems, you're going to be given three numbers again, and you're solving for the fourth. So in this one, we have these two numbers, and then we've got liters. So liters, that's one of our volumes, and we're trying to find the final volume. And we're given two temperatures in Celsius, which we will have to convert to Kelvin. So remember, we want same conditions on the same side of the equation. So it said it increased from 23 to 45. So that means this is the initial temperature. We'll call that T1, and this will be T2. And then initial volume, so this will be V1. So 23 should be on the same side as the 2.33, and then 45 will be on the other side. So for volume, we'll just plug that in right here. But for the temperatures, we're going to convert them to Kelvin. So for T1, that'll be 23 plus 273, which gives us 296. That's what's going to get plugged in. And then T2, 45 plus 273 is 318 Kelvin. And V2 is the one we don't know. So this one, the equation is V1 divided by T1 equals V2 over T2. We'll plug in the numbers we know. So V1 is 2.33 liters. Plug in our temperature in Kelvin, 296. V2 over 318 Kelvin. And we want to get V2 by itself. So we have a fraction with a denominator. To get rid of that, we're going to multiply by 318 on both sides. Plug that all into your calculator. 318 times 2.33 divided by 296. All these numbers have 3 sig figs, so we want 3 sig figs in our answer. And put that over here. V2 comes out as 2.50 liters. And that's our final answer. So most people can do these ones as the biggest issue people run into with both basically any gas law problem is that they forget to convert to Kelvin. Make sure you remember to do that for any time temperature shows up. That's the biggest issue they run into this. For these ones, for the ones where the temperature is on the bottom, that gives people a little bit more issues with the algebra. All right, so let's scroll this down. Let's look at our second example. So this one, we see STP again, and this time that's again standard temperature and pressure. This time we want the temperature from that, and at STP, temperature is 273 Kelvin. Now with this one, we've got milliliters and we have liters. These aren't matching because sig figs. It wanted 2 sig figs. So there are 1,000 milliliters in a liter. So for this one, we're going to rewrite that as 1,000 milliliters. For our course, we won't do too many where you have to convert the units, but you do want to make sure they match on both sides. So at STP, it equals 750 milliliters. Milliliters is our volume. These two will go together, and this will be our volume on the other side. So V1 is 750 milliliters. T1 is our STP 273 Kelvin. V2 is the 1000 milliliters. And then T2, we don't know. That's the one we're going to try to figure out. So again, equation V1 over T1 equals V2 over T2. Plug in our numbers. So we got 750 over 273 equals 1000 over T2. Okay, so this one, when we've got the variable we're looking for in the bottom, this is where people get mixed up on their algebra. So what you don't want to do is divide by 1000 on both sides, because that will leave T2 in the denominator, and we can't have that. So if you have a different way of doing your algebra, do what you're comfortable with. I've always used the cross multiplication, that little TP thing. So this crosses with this, and this crosses with this. So 750 times T2 equals, let's do the 273 there, times 1000. And now to get T2 by itself, we'll divide by 750 on both sides. So you would do 273 times 1000 divided by 750 in your calculator, and that gives you 364, and that's our Kelvin temperature. Now normally we would be done, but this specific problem says what temperature degrees Celsius. So if it asks for Celsius, you have to convert back, which means we subtract 273. If it doesn't say that, you don't have to do this part, but this one you do. Minus 273 gives you 91 degrees Celsius, and that's our final answer. All right, so that is Charles' law. With temperature, you're going to be cross-multiplying, or however else you would do your algebra. For volume, you would just have to multiply by the temperature on both sides. Make sure your temperature's in Kelvin. All right, that's it.